Okay, folks, this is the crib to test 4 from spring 2021. First problem. Given a 32.5 gram sample of potassium chlorate, how much potassium chloride could be formed given this equation? So K, something like 39. Cl, 35.5. O, 16. So, I have to figure out the molar masses of everything. So, the total molar mass of KCl3 is about 122.5. KCl, 39 plus 35.5 is 74.5. Okay, so we're doing grams to moles to moles to grams. Set that up. 32.5 grams of KClO3. 122.5 grams per 1 mole of KClO3. Grams cancel grams. For every 2 moles of KClO3, we get 2 moles of KCl. 2 over 2 cancels. And for every 1 mole of KCl, we get 74.5 grams of KCl. Moles and moles. So, setting that up properly, 32.5 times 74.5 divided by 122.5 gives you 19.8. 19.8. That equals 19.8. When sodium is thrown into water, it creates an explosion. What is the enthalpy of this reaction? So, to do enthalpy of reaction, it is the sum of the enthalpy of the products minus the sum of the enthalpy of the reactants. For the products, we have hydrogen, which is 0. We have hydroxide, 240.1 times 2. We have, well, that's sodium. We have hydroxide, which is negative 230 times 2, because there's 2 sodiums and 2 hydroxides. So, adding those together, and then the key here is to multiply by 2 to give us our, because there's 2 equivalents of them, 940.2. Okay? Now the reactants, 2 sodiums, but sodium is 0. And there's 2 waters. Water is 285.8 times 2. So 285.8 times 2 is negative 571. So minus a negative, so positive 571.6. So negative 940, positive 571. Negative 368. So negative 940.2 minus a negative 571.6. 368. Scrolling down. A 12-gram sample of unknown iron ore absorbs 785 joules of heat to raise its temperature from 25 to 131 degrees. What is the identity of that solid? So Q equals mc delta T. We're trying to find the C. So 785 joules equals 12 grams times my C times my delta T, which is 131 minus 25. 131 minus 25 is simply 106. So 785 divided by 12 divided by 106 equals 0.617, which is close enough to iron oxide. Now, okay. Last one on page 1. Space explorers testing the atmosphere of a new, hopefully inhabitable planet. Capture some gas in its test chamber. The balmy 37-degree gas registers a density of 2.48 grams per liter against an external pressure of 1 bar. What is the gas's molar mass? Density equals pressure times molar mass over RT. So rearranging that, density times RT over pressure is equal to molar mass. So 2.48 grams per liter times R, 0.08314 bar liters per mole Kelvin times temperature. And here is an important one. 37 plus 273 is equal to 310 Kelvin. 10 Kelvin. And then we divide by 1 bar. Bar, liter, Kelvin, Kelvin. So 2.48 times our R times 310 is 63.9. Not oxygen, that's for sure. A 20 ml sample of unknown acid is titrated with 8.18 molar base. It takes 37 ml of base to neutralize acid. What is the molarity of the acid? So MaVa equals MbVb. We want to know the molarity of the acid, but we're told that we have 20 ml of acid. We're told the base is 0.18. And we're told that it takes 37 ml of base. So, 0.18 times 37 divided by 20. So we have to divide both sides by 20. And that gives us 0.333. A. An 83-gram sample of sodium hydrogen carbonate, or sodium bicarbonate, is dissolved in 250 ml of solution. What is the molarity? Molarity is moles over volume, because molarity is moles per liter. So to do this, we need the moles of sodium bicarbonate. So 23, 1 plus 12 plus 16 times 3. So 23 plus 1 is 24, plus 12 is 36, plus 16 times 3 is a sum of 84 grams per mole. So 83 grams divided by 84 grams in 1 mole divided by my volume of 0.250 liters, because in 250 milliliters there's 1,000 milliliters in 1 liter. We do that, we'd have 3.95 molarity. 3.95. So 83 divided by 84 is 0.988 divided by 0.25 gets us to 3.95. What is the enthalpy of combustion using ethanol as a fuel source? So products over react. So it's the products minus reactants. So the enthalpy of reaction, the sum of our products minus the sum of our reactants. So negative 285.8 times 3 and negative 393.5 times 2 is going to be our products. So negative 1644.4. And our reactants is just going to be negative 277.6. Plus 0 times 3. So negative 1644 minus negative 277.6. Going to clearly leave us with 1367. 1367. An electric heater pulls in 600 watts, joules per second, of energy at the wall socket. It is shown an exothermic release of negative 598 joules of heat over the same period of time. What is the internal energy change? So delta U equals Q plus W. Well, it gives off an exothermic, this means joules of heat. And if it pulls in, absorbs 600 joules of energy, the answer should be positive 2 joules. Positive 2 joules. A marshmallow contains about 9.71 mils of air under 1 atmosphere pressure. If you put the marshmallow under a vacuum, achieving the pressure of 1 torr, what would be the volume of air in the marshmallow? Marshmallow is going to expand. So 9.71 milliliters at 1 atmosphere. So is a P1 V1 equals P2 V2. Well, in 1 ATM, there is 760 torr. So 760 equals 1 times V2. So 9.71 times 760 divided by 1 gives us 7379.6 or 7380. Which of the following statements does not apply to an ideal gas? Ideal gas is assumed to have no volume. Nope, that's an ideal gas. That's what it means to be an ideal. Ideal gas's rate of motion is proportional to its absolute temperature. Well, that is true of all gases, that the kinetic energy is proportional to the temperature. That's how we can understand that. Ideal gas is said to have no interactions. That's another ideal statement. Leaving only D. This is a real gas. Real gas condenses into a liquid below a certain temperature. That's what it means to be a real gas. How much ammonia could be formed using 50 grams of hydrogen and 25 grams of nitrogen? Well, really, 50 grams of hydrogen, there's no way that's going to be the limiting reactant. Hydrogen weighs so much less. Hydrogen is 2 grams per mole. Nitrogen is 28 grams per mole because it's 14 times 2. So you take the limiting reactant, normally would check both, but this one is really abundantly clear. 25 grams of nitrogen divided by 28 grams per 1 mole of nitrogen. Well, for every 1 mole of nitrogen, we get 2 moles of ammonia, and ammonia is 17 grams per mole. So 17 grams per 1 mole of ammonia. So you'd have 25 divided by 28 times 2 times 17. Gives you 30.35 or 30.4. Cobalt arsenide ores, or scutterudite, can be processed the following way: by mixing with oxygen, you form pure cobalt and arsenate byproduct. If 585 grams of scutterite is processed into form 102 grams of cobalt, what is the percent yield? Both of these last two problems are grams to moles to moles to grams. So cobalt, let's see, what's the molar mass of cobalt? Cobalt is, we'll just say cobalt is 59. Arsenic is 75. I'm rounding, but that's fine. 9 plus 75 times 3 is 284. 284. So we need to find out how many grams of cobalt could we form. So 585 grams divided by 284 grams per 1 mole. For every 4 moles of cobalt arsenate, we get 4 moles of cobalt. So 1 to 1 really. And for every 1 mole of cobalt, that weighs 59 grams for cobalt. So 585 divided by 284 times 59 means we could get a max of 121.5 grams. Now percent yield says we take the actual, 102, divided by my theoretical, 121, and that's going to give me, and then times 100, and that's going to give me my percentage. Gives me something like 84%. 84%. To detect leaks in methane, which is actually an odorless gas, 16 grams per mole, we tert-butyl-thiol. Tert-butyl-thiol. So, is added odorant. The sulfur is what makes it smell like rotten eggs. 12 times 4 plus 10 plus 32. How much faster would it fuse at 25 degrees through a pinhole? How much faster would methane fuse? So methane's going to leak out faster, but you don't need a lot of the tert-butyl-thiol to get that stinky smell. So the rate of methane, rate of TBT is going to be equal to the rate of the square root of the molar mass of 2 over the molar mass of 1. So 90 over 60. So 90 divided by 16 is 5.6. You square root that, and you get 2.37. So methane's going to leak out almost twice as fast, a little bit over twice as fast. Okay, number 14. How much NaOH must be dissolved in 500 milliliters to make a 0.325 molar solution? So to do this, we need to turn molarity to moles to grams. Molarity equals moles over volume, so molarity times volume equals moles. And then moles equals mass over molar mass. So we're going to need the molar mass. Sodium is 23, oxygen is 16, hydrogen is 1, so a total of 40. But we're going to have moles times molar mass equals the mass. So 0.325 moles per liter times 0.5 liters. We do that, that gets us 0.1625 moles, and if we multiply that by 40 grams per mole, we get 6.5 Last two. 55 mils of N2O is captured via water displacement at 35 degrees. Under a total atmospheric pressure of 755 torr. The pressure includes a small amount of water vapor. How many moles of N2O were captured? 35. So step 1, P N2O is going to be equal to the P total minus the P of the water. 755 torr minus the 41.2 torr. That's going to be 713.8 torr. So that pressure, 713.8, we're going to divide by 760 to get this into atmospheres. So that's 0.939 atm. 35 degrees, we got to turn that into Kelvin. That becomes 308 Kelvin. And volume, we need to turn that into liters. So that becomes 0.055 liters. 0.0, so PV over RT equals N. 0.055 liters times 0.939 divided by my R, 0.08206, times my T, 308, and that gives us my answer of 0.00204. 0.00204 moles. Last one. What mass of magnesium is needed to react with 125 grams of iron 3 oxide? Well, iron is 56, 2 plus 16 times 3. We said that's 160. At magnesium, it's about 24 grams. So grams to moles to grams. 125 grams of iron oxide divided by 160 grams per 1 mole of iron oxide. For every 1 mole of iron oxide, you would need 3 moles of magnesium. For every 1 mole of magnesium, it weighs 24 grams. 125 divided by 160 times 3 times 24 is about 56. Since I rounded so much, it's actually 57. Because that's actually 24.3. It's close enough. So that was all the math needed to do this entire test. Even moving as fast as I did, that's still 24 minutes. So use the 2 hours. Don't feel like you have to rush it. Take your time. Please note, look at all these useful information things. We got Avogadro's number. We got how to turn Kelvin into Celsius, Celsius to Kelvin. We got moles is mass over molar mass. Molarity is moles over volume. Percent yield. Delta U equals Q plus W. Q equals MCAT. Delta H reaction is sum of products minus sum of reactants. Delta H, we didn't need that one, but grams to moles to moles to grams. M1V1 equals M2V2. There's our R. P1V1 equals P2V2. V1 over T1 equals V2 over T2. PV over T1, PV over T2. PV equals nRT. Density equals pressure times molar mass over RT. Dalton's law, we didn't use that one, but there's the fusion. There's our generalized van der Waals gas equation. And here's a conversion. Atmospheres to torr to millimeters of mercury to psi, bar to Pascal. So please note, these are going to be there for you. Thank you and good evening.